Hello, in this video, we will introduce dynamic memory allocation. So we're going to use the new operator to create persistent memory at runtime. Let's look at this. Writing this reverse function. So I'm going to write this reverse here is this time we are not going to change this original list. So we're going to reverse creating a new list. And so this new list is returned. So the original one is not reversed. For this, I'm going to have this program here is reverse. I'm trying to write it. So here is the main. And now this is reverse. And see what I'm doing here. I'm going to get a temporary result here. So reverse everything from list, but I'm not changing the list. So list is still const and return result. So this is the result is returned. And now after that, I'm going to print the array. So when you run the program, you're going to be very surprised to see the output from this result of reverse. So this is the original is 1, 2, 3, 4, 5, 6. Reverse, you should have 6, 5, 4, 3, 2, 1, right? But what you get is 6 is right. But what are all the others? They are not correct. So what happened? It is because of this. This array, when you create it, so it is allocated in the memory. So where the memory is, it's on the stack. So all things locally in the function are allocated on the stack here, the call stack. So when you invoke a reverse, so reverse is on top of the main. So reverse is right here, and inside the reverse, so this is a locally static allocated array. So it's on in the active version frame on the stack, it's allocated on the stack. So when this reverse is finished and result is actually gone. So you cannot get a hold on the data. That is the problem. To make this happen now, we're going to have to use a dynamic memory allocation scheme. So what we have to do now is using this pointer here. So we're going to use this pointer result. Result is what? Result is new int bracket 6. So this is the syntax to create the memory. So this is the dynamic memory. It's not going to be allocated on the stack. It's going to put space, it's called a heap. Outside the call stack, it's a heap. So when this function reverse is finished, you still have this result. Now with just this change now, look, you run this program one more time, what happens? It will give you the correct answer. That's magic. So, but the reason is right here. This is so-called persistent. After the function is finished, you still have it. So that's persistent memory. All right, so here's the syntax, new. You can use new. That's the one we just saw it create an array. You can create anything. You can create a new just for a single variable, int variable, new int. And so always when you create a new, how do you access it? Through a pointer. So here now, from now on, you can use this if you want to create something dynamically, so you don't know the size of the array. So here you can prompt the user in the program, enter the size. Now you can create a new array using any size you just entered when the program is executed. So this is called dynamic memory allocation, and it's allocated at runtime on the heap. It's a heap. It's the HEAP. That is the term referred to the dynamic storage, permanent persistent storage. So as long as you don't do anything, it's there, but you need to destroy it if you no longer need it. So how do you do this? You need to have this is the So let's look at this. It's the delete. So you need to, if you don't no longer need this memory, delete it. So this is deleted for a single object or variable dynamic created. For a bunch of them using array, so you use delete brackets list. Now, what happens, let's see if you have something like this. This is X here, right here is 10. So now you're gonna assign this, the address of X to P. So can you do the delete P? No, that's not right. Delete is only for the dynamic created. What is dynamic created? Is a new. It's at runtime, use new. So this is statically at compile time, it's created. So this you'll get error. Now let's look at this one right here. I have this new int, we created new int. So that's a memory. I don't have any value initialized for that int in the memory. So now I'm gonna assign 45 to this P, that's fine. So here now I'm doing this again. Look at this new int again. So now you're creating a new object, and this new object is pointed by P. What happens to the previous object? That becomes a garbage. So garbage is a memory leak. That's what happened very often. You run a program and gradually, and you have a lot of memory brooded, and because it was not properly cleaned. So that's a memory leak. Let's look at this to see why we have that memory leak. So here, the first new right here. So when you have the first new right here, and this is the new right here, this is here created, you assign to P right here. So now you assign this 45 here, so this is fine. But what happens, you have another new, so another new here, this is now the garbage. That is all for this section on dynamic persistent memory allocation. Thank you for watching. See you on the next video.